Oops. Okay, so I'm going to save you listening to me reading everything at the top there. I believe you can read that on your own. We're going to get right to this. And so with the example there, we see that there are a couple ways to name that line. We are actually going to ignore the one that involves using a word. And we're going to use those symbols on top, which have an arrow on both sides, denoting that it's a line. And so a line can be read either direction because it extends forever in both directions. And so that can be read as line TS or as line ST. So moving on to number 1, we're going to have line segment CD. And our bar across the top does not have arrows on it because it is a line segment, not a line. Alternatively, we could write this backwards as DC because it's a line segment and it can be read either direction. Number 2 is array, and so it can only be read in one direction. It has to be read from the endpoint in the direction that goes and continues forever. So this is going to be ray XY with an arrow pointing toward Y because that's the direction that the ray is traveling. We cannot name this ray YX. That is not acceptable, and we are not going to do that. Okay. Moving on to the next ray, we have ray QR. Again, it's a ray, so it only has one name. Next, we have point L, and we'll just say L, or what do they say up here? Do they say we have to say the word point? Most of the time, I'm going to go ahead and put point L. I don't like writing words in geometry, but in this case, I sort of have to point L. Next, we have NO. And it's a line segment, so it could be read either direction, NO or ON. And next we have a line UV. This is going to have an arrow on both ends because it is a line, and it can be read both directions, so it's UV or also VU. Next we have line HI. Again with arrows on both ends because it's a line, and it can be written backwards, IH. And lastly, we have ray KJ, so KJ. And it is a ray, so it can only be read in one direction. Okay, on to the second page. We have sort of the same information at the top, although we are adding parallel lines, and this time they did put the little correct arrows on there to indicate that they are parallel, which on a worksheet that comes later, they do not. And so let's talk for a moment about parallel and indicating that lines are parallel. So we could have two lines that look like they're parallel, like the ones I'm going to draw here. And if I was to ask you, are those parallel? You might say, well, yeah. Well, you can't. In geometry, unless we are told through symbology or in words that things are parallel, like two lines are parallel, then we can't assume that. So these two red arrows here tell us that, hey, those two lines are parallel. Now, if you have multiple sets of parallel lines, the way to delineate that, obviously the lines that I'm drawing the green arrows on are not parallel to the lines that have the red arrows on them. And so what we do if we have multiple sets of parallel lines is we say, okay, the lines that each have one arrow on them are parallel to each other, and the lines that have two arrows on them are parallel to each other. And so that's how we show parallel lines. Parallel lines are lines that never cross. Intersecting lines are lines that do cross. And then lines that cross at a right angle are perpendicular. And as with the arrows showing that the lines are parallel, we cannot assume that these two lines that I'm about to draw are perpendicular. It could be like 90.5 degrees or 91 degrees or 89 degrees. The way that what we need to have proof when we start something that it is perpendicular is that little box drawn in the corner. That tells us explicitly, hey, these lines are perpendicular. So with that, we're going to go down here and name each line, segment, line, or ray. And remembering with rays, we can only have one name because it has to start at the point and go in the direction of the line, so CD. This one's a line, so we can name it CM or MC. Next, we have a line segment, XY. No arrows on our line, or YX. And this one is AB. Arrows on both ends, or BA. BC is this line segment, or CB. We have ST with arrows on the end because it's a line, not a line segment, and then TS. EF is the only name for this ray. DE is the only name for this ray. That's the arrow should be. Even though the ray is pointing to the left, our symbol always points to the right because we read left to right. So this one can be YZ or ZY. All right, these lines are intersecting. These lines are parallel. And again, we know that they are parallel because they have these marks telling us, hey, we are parallel. If they did not have those marks, even if they look parallel, we cannot say that they are parallel. And these two lines are perpendicular. And we can tell that it's perpendicular because of this box right here. As with parallel lines, if that box was not there, we would not be able to make the statement that they are perpendicular because we could not tell for sure. All right, and we have the same words on this side with the addition of one word, the plane. And so we can think about a plane like a giant piece of paper that goes on forever in all four directions. It's a flat surface that stuff like lines and points and rays sits on. So, naming these things, we have MN, and MNM. This can only be called ST because it is a ray. This is UV or VU. These are shown to be perpendicular, intersecting, and parallel. And last for us, we have this kind of wacky figure here on the right. We're asked to write some true or false statements. The figure is on plane W. And so it says plane Z there, so that is false. This is on plane Z. Most of the time, we're actually never going to deal with planes, and so you can kind of forget about that for the most part. The X is made of rays. So the X in the middle, is that made of rays? No, it is made of line segments. JK and LM are parallel. So JK, LM are parallel. I'm going to say the word maybe because there are no arrows to prove that they are. They look like they are, but there's nothing there that tells me, yes, they are parallel. EF and GH intersect. Again, I'm going to say maybe. Because if we continue those lines to the right forever, they may intersect because there's nothing on there that shows us that they are for sure parallel. All right. If those things had these lines like this, we would be able to tell that for sure they are parallel, but they don't have that. So we do not know.